Don't try to learn reactive programming. Reinvent it inside out with signals. Learning operators is the biggest mistake you can make. You have to make your own operators and reactive variables so that you understand what everything is actually for. A reactive variable is one that broadcasts when it changes. This means that it has an array of subscribers, functions, called when the value changes. From an outside perspective, it is a function that listens to the change. And if you make it return another reactive variable that's bound to the previous one, you just created a reactive operator. Now, whenever the first thing changes, everything down the reactive variable chain or tree or mesh will recalculate. Nope, this is not normal programming. This is programming that has been twisted and turned at strange angles. The need for reactive programming is extremely real. When you convert the variables that often change in your program to reactive variables, whenever there is a change, your program automatically reacts. It automatically updates. The changes ripple through pipes, trees, and networks of functions that add up to update the running program state. Yeah. When creating a layout engine for a game or a user interface, for example, you can't just add heights to get the correct number of the container. No. Because when a height changes somewhere, perhaps from user resizing their window or web page font or some label wrapping, you can't do anything with that new value. Nothing. Nothing at all. You have to rerun your entire layout, or at least all the children that are affected. You have to re-render. But when all the dynamic variables in your program are reactive variables or signals, wherever that value is used will simply change, and wisely so. So if you have a stack of buttons in a box and one of the buttons resizes because its label wraps, only that part of your program that initially calculated the box height will rerun. And then other components that surround it that depend on the height of the main container will also update. It's because that calculation depends on all the heights of all the buttons, which are all reactive variables. Reactive variables are objects, which means that they can do a lot more than just sit there holding a value. They can ask the browser what that value should be. Indeed, a couple of days ago, I created a fake signal or reactive variable that does not accept a value, but an HTML element, something on a web page, as it relies on the browser to set its value, as it measures and continues observing dimensions of the selected HTML element. And yes, to your reactive operators, that looks exactly like a normal standard variable. But it sets itself and turns itself off even when no longer listened to. Perhaps the most powerful feature is being able to update your calculations by simply throwing in a new reactive variable into your signal set. If you want to, for example, introduce a clever gap property for your button layout, you just add it in and multiply it by the number of buttons that are there minus 1. In standard programming, you would worry what could break. In reactive programming, The variables and calculations come first, and they take care of themselves. But what really speaks for reactive programming is the result. You go from 250 lines of "this will take me a while to grasp" to 3 lines of code that will make your coworkers retire on the spot. Some because of the beauty of it, but most just out of the intimidating strangeness of the reactive approach. Which is why it is so amazing to start your programming journey with asking the AI to make you a simple and lightweight signal implementation that 1. Ignores nullish values, 2. Only notifies when the value actually changes, and 3. Instantly executes the subscription callback on subscription if the value is not nullish. Tell it to use a set for subscribers and return an unsubscribe function from the subscription function itself for ultimate comfort. And then you just ask it to extend your signal class with map, filter, scan or reduce, and combine the latest. This whole thing could be as short as 30 lines of code. But you start learning programming right at its heart, becoming more and more powerful with every new operator you study, comprehend, adopt, or flat out invent, up until you are just so OP, overpowered, that other programmers around you will seriously consider retirement. To people who don't know that they need to start with a lightweight signal and some base operators to figure things out inside out, reactive programming looks indistinguishable from powerful magic.